There's a lot of information in this first section of Chapter 9, because not only are we doing circles, but we have parabolas in the same section. Parabolas have interesting properties, and you can get some idea what those properties are by thinking about how a flashlight works. So I'm going to draw a very simplified flashlight. And it might look like something like this. The batteries go in here, and you have some kind of a lens inside, and then in here you have a little bulb, and the bulb produces light, and this light reflects off the lens, and no matter which direction the light comes off of the bulb, it goes in the same direction. It comes out of the bulb, hits the reflecting lens, and goes like this. It does the same thing on the bottom. If it hits here, it goes straight out. If the light hits here, it goes straight out. And this property of the lens in a flashlight is why you see all the light seemingly focused in one patch in front of the flashlight. Now, let's suppose that we take this flashlight, which is pointing this way, and we turn it around so that it's pointing upwards. And this lens right here actually represents the parabola. Well, the Greeks discovered that there are only two geometric features necessary to describe the shape of a parabola. One of them was this dotted line called the directrix, and the other is a point called the focus. So F is for focus, and the focus of a parabola corresponds to the light bulb in the flashlight. Now, why do they call it focus? Well, if you think of the light rays as going into the flashlight instead of going outward, then the lens would focus the light rays onto actually the filament of the light bulb, which is located at the focus. So anyway, that's a little trivia why they call it the focus. So the real question here is, how do we describe a parabola using these two features, the directrix and the focus? Well, we start by taking a point on the parabola, which this is kind of like what we did for the circle. This is the point x, y, and we also pick up a characteristic point from the parabola. For the circle, it was the center. For the parabola, it will be this point, which is called V. And V is for vertex. Now, with these things marked, we have everything that we need to explain kind of how you get the equation of a parabola. Instead of measuring the distance from xy to the center, we actually measure the distance from xy to the focus, and we also measure the distance from xy to the directrix. So that's kind of interesting. Instead of having two distances, instead of having one distance like we did for the circle, we have two distances. And the relationship is that these two distances must be equal. Now, using this and the distance formula, we could work out the equations, but I'm going to kind of shorten it up a little bit. That derivation is a little bit long, and I think you might fall asleep if I did it. So let's just keep in mind that the vertex is located at HK, and this allows us to write the equations of a parabola, and the standard equations are x minus h squared, okay, equals 4p y minus k, and y minus k squared is 4p x minus h. Oh my gosh, now you're going to ask me, why do we have two equations? Well, parabolas sometimes go this way, and parabolas sometimes go sideways. Now the ones that you're used to are the ones that go upward. And the ones that go upward, the x is always squared. So this is for a parabola that looks like this, and this one is for a parabola that looks like this. Now, they can face up, or they can face down, they can face right, or they can face left. And we'll get into that in just a couple of minutes. Okay, I know what you're asking. What's the p? Okay, the p is this distance right here. This is p, is the distance from the directrix to the vertex, and then it's also right here. This is also p. So from the directrix to the vertex is p, and from the vertex to the focus is p. And this means that the vertex satisfies the requirement that d1 is equal to d2, because its distance from the directrix and from the focus is the same. And this is kind of a special distance that shows up in the formula, and that's why we give it a special letter, and it's p.